Hi there, we are students from ISIT315, Semantic Web, and today we are going to present about our assignment 5, which is an ontology about plants.
Mm.
Plants domain have many interesting concepts that can be portrayed or modeled in the form of ontology classes. We have found out that even for a sexuality concepts of a plant can be complex, as the sexuality of a plant cannot be determined accurately by a single factor, unlike animals or humans. There are many flowering and non-flowering plants that possesses different characteristics to determine the plant's sexuality, either it's unisexual or bisexual. Plant sexuality is a complex topic. Therefore, we illustrate the topic by linking multiple ontology classes that define the plant sexuality of a flowering and non-flowering plant. The plant sexuality class are differentiated through its unique characteristics. Such unique characteristics are, for example, male flower is known to be flower pollen producers, while male conifers are known to have tight scales. The other way around, a female flower is known to be flower seed producers, while the female conifers are known to have loose scales. This provides a near complete and clear scope in defining the plant's sexuality. Plants could also have male or female flower, male or female corn, both on the same plant. Plant can grow in a different natural habitat and environment conditions. Therefore, in our ontology, we have modeled this to represent that plants from different environments have different characteristics, which will be used to classify them into their respective classes. For example, underwater plants are classified based on their length of root, length of stem, and waxy leaves. Plants can also reproduce asexually, sexually, and crossbreeding, which will produce a hybrid plant. Our ontology will also model these plant characteristics to illustrate how plants are reproduced from. In addition to that, plants also can have relationship with each other in the form of epiphyte, where a plant grows upon another plant merely for physical support, and parasite. This will also be modeled in our ontology. Other elements about plant that we have modeled into our ontology includes plants that are threatened for extinction, extreme dangerous plant, carnivorous plant, multipurpose plant, plants that provide industrial product value, medical value, nutritional value, and as well as plant poisonous level partition. All plants are not woody in nature. There are some plants that have soft stem. With this in mind, we have modeled this into our ontology as well, with the characteristics of plant that classify which type of plant it belongs to, either woody or non-woody plant. We build our ontology model by referring to an existing ontology search engine that provides a structured vocabulary and database resource. It provides useful information such as plant anatomy, morphology, growth, and development of plant genomics data. With this information, we can successfully create flower body part class component from this resource that is shown from the slides. As you can see, these are some of the uh, resources that we use to refer while building our ontology. We have also utilized knowledge from knowledge-based areas such as online article, website, and etc. to create the ontology class that helps to define concepts such as male flower, female flower, bisexual flower, male cons, female cons, as well as characteristics that define flowering and non-flowering plant. We have used websites to gather information about plant threatens about plants threatened for extinction and the average price range of expensive plant. Now I'm going to explain about some enumerated terms of object and property. These are some of the enumerated terms of object design for our ontology. Epiphyte is a subclass of a plant which is used to describe a plant that grows upon another plant or object merely for physical support. We use this term on our ontology to describe plants that has relationship with another plant. Hemerophyte flowering plant is a subclass of plant which is a plant of a flower that has both male and female reproductive organ within the same flower. We use this on our ontology to describe bisexual flowers. Hybrid plant, subclass of a plant, is a plant that is a byproduct of two distinct parents. In our ontology, we have described any plants that have at least two plants will be classified as a hybrid plant. Monoecious conifer plant, subclass of plant, is a plant that have both male and female reproductive organ and does not have any flower. We can classify plants as monoecious conifer plant when a plant has some female conifer and male conifer on the same plant. Monoecious flowering plant is a subclass of a plant, which is almost the same as the previous term. However, the only difference of it with this term is that it has flowers. We can classify plants that fall under this term when they have some female flower and male flower on the same plant. Multipurpose plant is a subclass of a plant. This plant has multiple purpose or usage. We can describe plants that are multipurpose when they possess at least two properties. Those two properties are industrial product value. Those properties could be one of industrial product value, medical value, and nutritional value. Bisexual, subclass of plant sexuality. Bisexual plants are plants that contain both male and female reproductive organs in the same flower. We classify plants as bisexual when they have some bisexual flowers. Bisexual flowers are being classified only when a plant has a minimum of 6 flower body parts, which includes 4 female body parts and 2 male flower body parts. Only then the plant is considered to be bisexual. Unisexual is also a subclass of plant sexuality. Unisexual plants are plants that contains male and female reproductive organ in separate flower. We classify plant as unisexual when it only has either one female conifer, male conifer, female flower, or male flower. Dioecious conifer plant. Dioecious conifer plant are plants that consist of male and female organs in separate individuals and does not have any flower. It is unisexual as it can be either male or female, but not both at the same time. With this reasoning, we have defined any plants that either have some male conifer, female conifer, but not both, to be classified as dioecious conifer plant. Dioecious flowering plant are the same as the previous description, with the only difference of that it has flower. Since it's a flowering plant, we have defined any plant that either has some male flower, female flower, but not both, to be classified as dioecious flowering plant. For the property terms, we have has gametophytes, has host relationships, has desert plant characteristics, has corn, has underwater plant characteristics. These are some enumerated terms for properties. Has gametophytes is a functional property used to describe a plant that either has male or female gametophytes. Gametophytes is responsible in production of gametes, which is a reproductive cell. The gametes can either be male or female cell. So a plant can either have male gametes or female gametes, and the range of gametophytes is a superclass of the male gametophytes and female gametophytes called gametophytes type. Has host relationship is a symmetric property used to describe relationships between two plants. Has desert plant characteristics is a property used to describe plants that has some desert characteristics. Such characteristics include large diameter root, sharp spikes, and small leaves. Has corn is a property used to describe plant that has either male or female conifer. The range of this property is a superclass of female cons and male cons called constack. Has underwater plant characteristic is a property used to describe plant that has some underwater characteristics. Such characteristics include long roots, long stem, and waxy leaves. Now I'll let Kelvin explain on the ontology class.
Okay, now today I'll explain about ontology class. There is a total of 88 class in our ontology, but for the sake of our presentation, we only present the 7 of the unique classes today. Okay, I'll go to the protology now to show you guys the total 88 classes that we have. As you can see here, we have a total of 88 classes, which is quite a lot. But for today, I only talk about the 7 unique classes that we have. The 7 unique classes that we have are woody plant class, underwater plant class, Kaler class, third generation plant class, bisexual flower class, monoecious flowering plant class. So I explained what makes all of these class unique individually in the protology. For woody plant class, this class is unique as we apply not only object property restriction, but also data property restriction to identify whether a plant is woody or non-woody in nature. As you can see here, in order for a plant to be considered woody, they must have a plant characteristic of some rigid woody stem, thick cell wall, and also have a lifespan years of more or equals to 5. Next, I would like to talk about underwater plant. In terms of underwater plant, this class is unique as we apply object property restriction in the form of enumerated class. As you can see here that this plant has to be grown in some deep water level, and also we apply cardinal restriction as this, in order for a plant to be considered underwater plant, they have to have underwater plant characteristic that is minimum of 2. As you can see here, deep water level class is an enumerated class as deep water level class can only consist of individual of exopelagic zone, metapelagic zone, epipelagic zone, heteropelagic zone, and mesopelagic zone. And you can see here the underwater plant characteristic that we have is long root, long stem, and waxy leaf. In order for a root to be considered long, they must have a length of more or equals to 30.0. And in order for a stem to be considered long, they have to have a stem length that is more or equals to 20.0. Third, I'll talk about Kaler now. Kaler is a unique class in our ontology as this is our answer to the limitation posed by protology in creating a hybrid plant. As you can see here, the protology lack of a proper functionality that enable us to identify a plant with hybrid, as this logic is not 100% correct, as in order for a plant to be a hybrid plant, they must have a minimum of 2 parents, but must have a minimum of 2 distinct parents. Hence, as a lack of a 2 to show that apply this logic, we have created a Kaler class, which is a hybrid plant that have a parent of a specified 1 Brussels sprout plant class and has parent of minimum 1 specified kale class. As can be seen here, Brussels sprout is a plant that has a characteristic some leafy and has some average size that is less or equals to 4.0, and kale is a plant and has plant characteristics some leafy. Now I'll talk about the next class is third generation plant. This class is unique as we apply complex logic in order to identify a third generation plant. In other words, that in order for a plant to be considered a third generation plant, they must have 2 generations prior to it. Hence, you can see the logic as in this plant must have a predecessor, some plant, and has some predecessor some first generation plants, implying that the third generation plant is a plant that has 2 predecessors prior to it. Now I'd like to talk about bisexual. As Vignesh mentioned before, that plant can be bisexual or unisexual. In terms of bisexual, a flowering plant is bisexual if they have some flowers, some bisexual flowers. Hence, in order for us to really mimic the real life example of a bisexual flowering plant, we have connect a plant to be bisexual if they have bisexual flowers, which is the next class I would like to talk about. Bisexual flowers is a class that has body part minimum 6 flower body parts. Hence, you'll be asking why it had to be minimum 6 flower body parts and not minimum 4 female flower body parts and minimum 2 male flower body parts. The answer because is this restriction is also applied in our female flowers and male flower respectively. Unfortunately, protology is not smart enough to understand the differences in both of these restrictions. as we cannot apply both restriction in other class, as it can cause conflict. Hence, we have created a new logic has body part minimum 6 flower body part in order to overcome this issue. Next, I would like to talk about monoecious flowering plant. Monoecious flowering plant is a plant that has flowers, some female flower and some male flowers. This class is unique as compared to humans. Humans can only have one gender, which is male or female, which is the common norm. But in terms of plant, we want to show that for plant, it's okay for a plant to be able to have some female flowers and some male flowers, which is different from a normal human that which only can have one gender, one type of gender. In terms of object property, we have 16 object property. However, for today's purposes, we only will explain 5 of the most unique ones. Now, in the first unique object property that I would like to explain today is the has diet of. This object property is used to provide a link between a plant and a range of prey, which to show that a carnivorous plant should only have a maximum of one type of prey. Next, I would like to talk about has host relationship object property. As Vignesh mentioned before, epiphyte is a plant that can have relationship with another plant. Hence, we demonstrate this logic by creating a has host relationship object property, which shows that a plant can have a relationship with another plant, and this relationship is also vice versa, which is why it's symmetric in nature. Next, I'd like to talk about has predecessor. Has predecessor is an object property we created in order to demonstrate the logic behind the first generation plant, second generation plant, and third generation plant class. As example, in order for a plant to be considered a second generation plant class, they must have a predecessor prior to it. Hence, this can be shown in this object property. An example of this can also be used in the third generation plant class. As you can see, it is transitive nature because if a third generation plant class is known also to have the predecessor that of its second generation plant class. For example, if a second generation plant class has a predecessor of plant A, the third generation plant class should also have a predecessor of plant A. Hence, why is it transitive in nature, this object property. Next, I would like to talk about has successor. This object property is the inverse of has predecessor object property functionality. And lastly, I would like to talk about has underwater plant characteristic. This object property is unique. As you can see here, there is a no that we do not place a domain to define it. The reason is because we would like the reasoner in Protology to help us to define it for us. As you can see here in the class here, in order for a class of underwater plant to be identified, in order for an individual to be identified as an underwater plant, they have to grow in some deep water level and also have some underwater plant characteristic minimum of 2. Hence, we are asking the reasoner in Protology to help us to infer this knowledge in order to find any plant individual that fulfill this criteria, as you can see here in water letters. Okay, now I'll talk about data property. In our ontology, we have 8 data property. However, for today's purposes, I only explain 5 of the most unique one. For the first data property I would like to explain is the has cost per plant. This data property is important for us to identify cheap plant and expensive plant. As can be seen here, expensive plant is defined as a plant that has cost per plant equal or more than 5,000, while cheap plant is a plant that is not an expensive plant. Next, I'll talk about has leaf width. Has leaf width is a data property that we use in our ontology to define small leaves. As you can see here, that we do not place a domain here because we would like the reasoner in the Protology to help us infer what individual leaf is considered a small leaf. As you can see here, when we run the reasoner can help us to identify any individual leaf that is considered small, as we do not place the domain in it, as we want the reasoner to help us infer what individual leaves are considered small if it fulfills this criteria that a small leaf is a leaf that has width equal to 8.0 or less than 8.0. Okay, next, I'll talk about has lifespan years. This data property is important for us to create the complex logic reasoning for woody plant and non-woody plant. As can be seen here, this data property is used to define woody plants, whereby it's a combination of object property restriction, and data property restriction. Now let's talk about hash root diameter. Again, we do not place a domain in this as we want the reasoner in Protology to help us identify which plant is considered a root diameter of the individuals that we created when we infer it, as can be seen in this class, large diameter root. We did not create an individual for this, hence it doesn't show the result here. Okay, next, I'd like to talk about has total number of species. This data property is important because, as mentioned before by my colleague Vignesh, that not all plant is threatened for extinction. Hence, we want to know which plant is threatened for extinction. Hence, we allow the reasoner in Protology to help us infer this knowledge. As can be seen here, through the use of this data property, we can infer the non-extinction threatened plant and the extinction threatened plant.
So for this assignment, we basically have created around 50 individuals, but during this presentation, I'll be just picking 5 and show it. So the first individuals that I pick is Zerkil. So after I run the reasoner, these are the inferred knowledge that the reasoner has produced. So we can see at the first inferred type that the reasoner produced is a hybrid plant. So what is a hybrid plant is considered a hybrid plant is that a plant that has parent of minimum 2 plants. So as we can see here, we already include some object properties that state that bruiser kills has parent of curly kill and has parents of bedford bruiser sprout. So this reasoner will based on this and infer this knowledge. So the second infer knowledge is pellets. So in order to be inferred as a pellet, it needs to have a parent, minimum 1 bruiser sprout, and has parent 1 kill. So we already have included object property that shows that bruiser kills has parent curly kill and bedford bruiser sprout. So this is an individual of kill class, and this is the individuals of bruiser sprout class. So in order to be inferred as a multipurpose plant type, the individual will need to have a minimum of 2 properties. So since we already include 2 properties, anti-diarrhea and vitamin C for the bruiser sprouts, so the reasoner can use this information to infer this knowledge. For the non-extinction threatened plant type, a plant need to has a total number of species of over or equals 1000. So in this data property, we include that bruiser scales has total number of species of 20,000. So for this last inferred type, sexual plant offspring, in order to be inferred to this, the plant will need to have a minimum of 2 parents. So since we already include this, the reasoner can infer this knowledge. So the reasoner has also inferred the knowledge of bruiser kills, has close relationship with bedford bruiser sprout, and has close relationship with curly kill. So as we see in the object property, so has host relationship is actually the parent class of has parent. Therefore, the reasoner can infer this since we already include has parent object property for bruiser. For the second individual that I picked for this presentation is Venus flytrap. So after running the reasoner, these are the infer knowledge that the reasoner has produced. So the first one is carnivorous crab, So in order to be inferred as a type of carnivorous plant, as you can see here, it needs to has a diet of prey, of some prey. So since we already include the object property of has diet prey, the reasoner can infer this new knowledge. For the first generation plant, in order to be inferred as this, we didn't include anything. Therefore, the reason can infer to this because it doesn't have any successor that we include in the object property. So the last one is plant. Since carnivorous plant is a subclass of plant, therefore it can be inferred to this. For the third individual that I chose is Bedford Brussels sprouts. So these are the inferred knowledge by the reasoner. So in order to be inferred as a Brussels sprouts, an individual need to has a plant characteristic of some leafy and has an average size of some value that is less than or equals to 4. So as you can see here, we include has plant characteristic green leafy. This green leafy is individual for leafy class, and this has a ridge size of 1.2. So the reasoner used these two information to infer that this Bedford Brussels sprout is a type of Brussels sprout. In order to be inferred as an epiphyte type, the plant has to have a host relationship with some plant. So since the reasoner has inferred this has host relationship with Brussels kills knowledge, so this epiphyte types is correct. The fourth individual will be Pepper. The reasoner has inferred some new knowledge, hybrid plant type, sexual plant offering type for the pepper. In order to be classified as a hybrid plant type, the individual need to have a parent of minimum 2 plants. So here in the object property, we already include apple has a parent of apple and has a parent of pen. Therefore, the reasoner used this information to infer this new knowledge. For the sexual plant offspring, the plant needs to have parents of minimum 2 plants in order to be classified as a type of sexual plant offspring. So since we already include as parent apple and pair for apple, this knowledge can be inferred. So for the object property knowledge that the reasoner inferred as has host relationship apple and has host relationship pair. Since that in the object property, has host relationship is the parent class of has parent, so the reasoner can use this knowledge to infer to this new knowledge. The fifth individual that we choose for this presentation is Alaron Flamen Gen 1. After we run the reasoner, these are the new knowledge that we get. The first one is carnivorous plant type for Alaron Flamen Gen 1, which is incorrect in this case. The second one is first generation plant. In order to be a first generation plant, the individual cannot have any predecessor. In this case, we only include as successor of Alaron Flamen Gen 2 for this individual. So for the third inferred knowledge type, plant, so in the plant class, So in the first generation plant class, we already include that it is equivalent to plant class. So the reasoner will use that to infer this individual as a type of plant. So for this object property, we include has successor, allowance, Fleming chain 2, and the reasoner gives us new knowledge. Say that this individual has successors of allowance, Fleming chain 3. It is because in this individual, we include has predecessor Gen 1, has successor Gen 3. Therefore, it uses transitive of this object property to infer the new knowledge.
So as for the Sparkle query, we have created 15 of it, but in this presentation, I will only pick 5 to present. So the first one that I choose is created using construct. So construct is basically a query that will return a single RDF graph based on the condition in the return in the query. In this case, we use construct to construct a new graph with the condition of plants that has characteristic green leafy and takes time. The condition ensures that other plant that doesn't have the characteristic mentioned above will not be included into the graph. So after you run the reasoner, this is the results. It shows the plant and the object property plant characteristic and the objects that are associated with the object property. So for the second query that I have chosen is created using subquery. So subquery is a query within a query, which the outer query will use the result of the inner query to query its result. The objective of this query is to get the distinct plant that has a host relationship and prints out all the child of that plant and the plant itself. The inner query will select all the plant that has host relationship with another plant. So the selected plant from the inner query will be used by the outer query to get the child of that specific plant. So we also use distinct in this query so that there's no duplicate plant. So after you run the Sparkle query, in this case, we only get one result, which is the oak tree of spring. So for the third query, it is created using aggregate function. So the purpose of this query is to get the successor of the plant and calculate the sum of the stem of every successor of a particular plant. The condition in the where clause will retrieve the plant which has successor of some successor and get the stem length of the successor. All the stem length will be summed out using the aggregate function. And after you run the reasoner, here are the results. So these are the plants that have successor, and this is the total stem length. So the fourth Sparkle query is created using describe. Describe will return a single result RDF graph containing RDF data about the resource. So the purpose of this query is to describe the plant that has the properties vitamin C and antidiarrhea. The where clause in the query will filter the plants where only plant that has the property mentioned above, which is the vitamin C and antidiarrhea. Then the describe will only describe the plants that meet the condition. So after we run the Sparkle query, these are the results. So the plants will have bruiser kill, which meet the condition here, and it will describe all the RDF data about the resource. So for the last Sparkle query, It is created using construct, subquery, and union. This query will create a new graph which retrieves the subject, predicate, and object of this kind graph based on the condition of either the subject has property of some property or has diet of any plant. The most inner query here, the select statement will get the subject that has property and has diet of something. The outer select query will get the subject, predicate, and object that meets the condition in the inner query. So the construct will basically construct the RDF which meets the where clause below. So after running the Sparkle query, these are the results. So these are all the subjects that meet the condition, predicates, and object. Thank you.